Page 7 of the C programming notes, and we're just going to look at a couple other things you can do with pointers. So we could call this fun with pointers. So the first is arrays. So in C, when you have an array reference, an array variable, I guess, it's actually just a pointer, and you can use pointers to make arrays. So we can have dynamically allocated arrays, and this can have its uses when you don't know, how many of a certain type of object you're going to need to represent ahead of time, so you can allocate the space for it at runtime. So here's our example. I'll just say A for array, save the writing. Oops, that's malloc. And this time I want to create an array that can hold 10 integers. So I'm going to tell malloc to allocate enough space for 10 times size of int, where size of int is returning the number of bytes that you need to represent an integer. So now we got enough space for 10 integers, so this allocates storage for 10 ints, or I should say it allocates enough storage for 10 ints. What you actually put in there is up to how you use it. So now let's look at using this. So for int I equals 0, I less than 10, I plus plus. So this, when you have the int I equals 0 inside the for loop bracket there, that's something that you didn't used to be able to do in C, back in C89. That's one of the things that they added with C99, which is nice to have. And what I'm going to do here is just set each element of the array equal to its position in the array. So element 0 will have the value of 0, and so on. And so what's happening here is these square brackets, this array, these array operators do pointer arithmetic. So this here performs pointer arithmetic on A. So A holds, I'll just put that in single quotes there, A holds the address of the first element, and then square bracket I adds I times size of int to that address in A and dereferences. So then we can store the value there. Now the equivalent way to do this just using pointer notation is for int I equals 0, I less than 10, I plus plus, dereference A plus I equals I. That looks a little funny, because it looks like we're just adding 0, 1, 2, 3 to A, but actually with because A is a pointer to an int, when you add I there, that gets multiplied by the size of the int. So if an int is 4 and I is 1, we'll actually add 4 to the address, which moves us along to the next integer. Here's another little example of the pointer arithmetic. So let's just say I have pointer B, and I want to initialize it with to point to the fifth element of A. I can do this. So A is an address in memory, and we don't just want to add 5 bytes to that address. That would put us partway into the second int, which is not good. So this adds 5 times size of int, so probably 4. And then we could do something like printf %d \n dereference b, and the output in this case will be, what do you think? It will be 5. So it's b is pointing to the fifth element that we've already initialized up above in A. Okay, so that's one thing that you can do with pointers. Another thing that you can do with pointers is you can have pointers to functions. So function pointers. So here's an example. We can have a function that returns, let's just say, an int, and this is how we declare a pointer to such a function. So func pointer is just another variable, it's an identifier, and it points to a function that returns an int, and then the parameter list comes after in separate brackets. So let's just say that it takes 2 chars. I don't have to put A and B here, I could just have char comma char. And so what we got here is a pointer to a function that takes 2 chars as parameters and returns an int. And this is kind of weird, like why would you ever want to use that? I'll just say an example of where this is used is it's used in the qsort function, which is in standard lib.h. So qsort is the C library sort function, and it takes void pointers, and you actually pass it a function that knows how to compare 2 elements in an array. So that's where you need to pass in a function. So it's how you get, I guess, something close to polymorphism in C. Function pointers are used in functional languages. So Scheme is the language that CS teaches their first year students in CS 133. It's a functional language. I think that it kind of built on Lisp, which was one of the original functional languages. Haskell is a more popular functional language nowadays. But functional programming is showing up even in mainstream languages. So Java and C++ both have lambda functions now. A lambda function, this is all extra, but anyway, a lambda function is where you're calling one function and you need to pass it another function as a variable, as an argument, and you actually declare it in the place where you're passing it. It doesn't have a name, so it's an anonymous function or a lambda function. They're pretty cool, actually. They can make for some nice programming, but we don't have them in C, which is probably good for you, but we do have function pointers. And now I will actually show you where you are going to see these in this course and why I'm telling you about them. So in the real-time OS that we're going to be using, SimSys RTOS 2, in one of the header files, I think SimSys OS 2, there is going to be a definition that looks like this. So type def void pointer OS thread func underscore type void pointer, and I'm just going to write arg. It's actually argument. so when you call, so let's just, I'll show you an example of using this. So let's just say you have something like void my func. Okay, so it takes void pointer arg and it does something. Then later in the code, we can call the new thread function, which is part of the operating system we're using, and we would pass it myfunc. So that name is actually a function pointer, and then you pass it some other arguments, typically null and null. The first one is the parameter to your function that's going to be given to your function when it runs, and the other one is some attributes about the function that you can use to configure certain characteristics of it. Anyway, so you're going to see this in Lab 3. You're also going to see this in the, I think it's in the scheduling portion of the lecture notes coming up. So that's why I'm introducing function pointers now. Hopefully it'll make sense later. Okay.